How robots are made. Robots are human-made versions of animal life, machines that replicate human and animal behavior. Researchers in artificial intelligence have made significant advances in the science of creating intelligent autonomous machines. As computers have become more powerful, robotics research has taken off in several different directions, from autonomous vehicles to humanoid robots. Have you ever wondered how these various robots are constructed and programmed? Join us today as we will be exploring in depth how robots are made.
The process of paintwork on it. After we cast the body, I took it and I cut off the nose and we cut out parts of his skull and face and exposed different things. To put the hair on it, that got replicated by one hair at a time being punched into the silicone to achieve, I think, a highly realistic.
Robots are mostly built of everyday materials. Some specialized robots use titanium metal and structural composites of carbon fibers. The significant factors in the material selection of a robot include the operating environment and the required strength. For the robot's base, steel, aluminum, and cast iron are more often used. Aluminum is helpful for small or medium-sized robots. At the same time, steel is useful for giant robots and robots intended to operate in rough conditions, but would be too heavy for small or medium-sized robots. Rubber tires are commonly used for movable robots for quiet operation and a positive grip on the floor. Robots contain a significant amount of electronics and wiring, some of which are radio and some are laser-controlled. The cylinders and other motion-generating mechanisms have hydraulic oil or pressurized air. These mechanisms are connected to their control valves by silicone, rubber, and stainless steel hoses. Some exposed areas of the robots are covered with flexible neoprene shields and collapsible bellows to protect them from the environment. Copper is used for particular parts and wires, while brass is used in bearings. Good choice of raw materials is essential in making robots. Most common elements that are used in constructing robots. Number 1. Sensors. Sensors allow a robot to gather information about its environment, such as cameras that enable the robot to judge attributes of the environment, microphones that will allow robots to detect sounds, thermometers to sense temperature and pressure, and some complex sensors like LiDAR use lasers to construct three-dimensional maps of their surroundings as they navigate through the world. Accelerometers and magnetometers that allow the robot to sense its movement concerning the Earth's gravity and magnetic field, and so on. With the help of these sensors, robots can see and feel, which would help the robot perform complex tasks. Number 2. Effectors. The effectors are the parts of the robot that actually do the work. This could be any sort of tool that can be mounted on your robot and controlled with the robot's computer. For example, lights, hammers, screwdrivers, wheels, and propellers on a robotic vehicle, hydraulics that can be used for many moving parts of a robot, speakers that allow certain robots to talk to us or generate other sounds. These effectors are specific to the tasks that you want your robot to do. Number 3. Control systems. A robot's control system is the part of the robot that controls the robot behavior. It manages, commands, directs, or regulates the movement and function of various parts of the robot to achieve the desired result. The control system includes manual control, wireless control, and automatic control using artificial intelligence, and with technological advancements, the control system in robotics continues to develop and advance. The manufacturing process. Number 1. Design. Every robot begins with the design phase. This phase includes all the tasks needed to move from the manual process to the robotic cell's plan and materials. The overall system and procedures should be carefully planned as the robots can only do jobs they were designed or programmed to do. Therefore, workers responsible for them have to be fully educated and trained as well. The basic steps involved while creating a robot include research and gathering information, such as a robot's practical function or what my robot must do. This includes movement of the robot within its environment, the energy source or how the robot is powered, the appearance of a robot, such as its shape, form, and color, which are essential to the aesthetic design quality. Materials are another essential factor suitable for the design, including its cost and availability, construction methods and techniques such as cutting and shaping, molding, casting. All these specifications are part of this process, and it should define exactly what the design must achieve. Number 2. Assembling and processing. Once the robot is designed, the next step consists of putting the pieces of the robotic cell together, programming it, and installing the cell on the production line. The base, arms, column, and supports are all fabricated. The base is usually heavy to prevent the robot from tipping over. It is made by casting or by welding, then machined. The areas are machined with close dimensional control to ensure the proper fit and operation of the attaching components with the rest of the robot. Robots are assembled using elements such as electric motors, hydraulic cylinders, bearings, wiring, controllers, and other essential parts. The assembly begins with mounting traction motors, batteries, axles, wheels, and tires into the mobile robots, whereas stationary robots do not require these items. The moving columns and arms are sub-assembled with their respective drive motors and then attached to the base. Arms, wrists, and other parts are assembled at their specific positions. Some robots, such as industrial robots, contain 2,000 individual parts assembled by teams. These teams begin assembling components with the base and continue until it's complete and ready for testing and finishing. Once the mechanical assembly has been completed, the wiring and plumbing of the robot can be finished. The motors, sensors, and electrical components must have wires for power and to carry information back to the control computer. After assembly, the arms and column of the robot are sometimes covered with guards and shields to protect them from paint spray, welding sparks, or other hazards in the environment. Once the assembly has been completed, a robot is ready for installation, usually done at the user's end. If the robot is stationary, it is secured to the floor with bolts. If moving, a guide wire is buried into the floor for the robot to follow from task to task. However, lasers have been recently used to eliminate the wire. After installation, the robot manufacturer usually provides operation and maintenance training to the customer. Number 3. Inspection. When assembling and programming is complete, the robot must be tested to see if it does the job for which it was designed, or how well the design functions, if the product is safe to use, etc. Once the assembled robot is energized with power, a computer program instructs the controller to move the robot arm through a series of motions. Accurate recordings of these motions are made. If any problems are encountered, these are then corrected. The robot is continuously placed in operation for several hours to monitor and indicate any design problem, such as loose assembly or defective bearing. The robot is continuously placed in operation for several hours to monitor and indicate any design problem, such as loose assembly or defective bearing. Also, the trial run brings the electronics and hydraulics up to operating temperature as the controller is programmed with correction factors. The programmer can place the correction factors into the program with the machine warmed up to provide optimum performance. Creating a successful robot, the process requires knowledge and patience. It involves setting a clear strategy, weighing the pros and cons of different operating systems, programming the brain to carry out desired functions, and building the physical features that enable your robot's predetermined functionality. I hope you liked our today's video. Do let us know in the comments below. Don't forget to hit subscribe and click the bell icon to see more of these exciting videos. That's it for today. Thanks for